Good time of day, dear colleagues, and welcome back to our Research Methods course. Today we will discuss several models that are extremely handy and extremely frequent in our psychological research, namely multiple regression and general linear model. We'll start by taking a quick look at multiple regression. What is this method about? What are its assumptions? How can we apply it in our actual research? And what are the steps that we need to take in order to estimate regression and interpret it? And then we'll take a look at some more advanced things that you can do with regression. For example, how can we test interaction effects in multiple regression? Or how can we introduce nominal variables in multiple regression? And then we'll take a look at path models. A very quick look just to give you a general idea of what these models are about and their assumptions and their basic ideas. And we'll spend quite a while looking at general linear model, which is basically a general unifying framework for ANOVA that we discussed last time and for multiple regression that we are going to discuss today. And to conclude our session, we'll focus a little bit on more tricky linear models such as MANOVA and hierarchical linear models and linear mixed models. So before we begin our discussion of multiple regression, let's try to broaden our outlook on the possible models that we can build. To serve as an example, I have put here a little correlation matrix that comes from our study with Tamara Gordeeva, where we had slightly over 200 high school students, and they completed 2 questionnaires on self-esteem and on optimistic attribution of successes, and we also calculated their grade point average for the last semester. So what is the cause and what is the effect? There are different ways to model the same data. We can say, okay, maybe children's self-esteem increases after they get good grades. Or maybe good grades are a result of good self-esteem. And the same goes for optimistic attribution of successes. For example, we can say maybe if you have a high self-esteem, then if you have obtained some kind of success, you will say, oh, it's my achievement, rather than just luck. So you are going to attribute it in a more optimistic way. Or maybe vice versa. Maybe it's self-esteem that is a result of optimistic attributions. So there are different ways to put these variables together. And just to give you a little brain exercise, how many models do you think are possible for just these 3 variables? After you've given it a thought, let's explore the possible answers. So obviously, when we just plot a correlation matrix, it is the simplest possible model for this kind of data, where we have optimism, self-esteem, and grade, and they are all just associated, and we have no idea what might be the cause, what might be the effect. We just calculate our correlation matrix and we relax. This is what people did in the 1920s and 1930s, when basically they could not do anything but correlation analysis. Computers were not around, calculating regression was an impossible task. Try to calculate it by hand and you'll see when there are several variables, and not speaking even of more complex models. So the 2 models that we can think of and that we are probably familiar with, the model here on the right on the top, which I labeled here common cause model, when we assume that maybe it is because of self-esteem that children form optimistic attributions and they get higher school achievement. So self-esteem is like a common cause of optimistic attribution of successes and grades. And we can try to separate the common variance that optimism and grades share and that is shared with self-esteem, and see if the association between optimism and grades remains. So the question is, does self-esteem explain the association between optimism and grades? And this simple path model, maybe you recognize it already because we discussed it in our lecture 6, I think, when we focused on correlations. And if you remember this formula for partial correlation, when we try to extract the variance associated with one variable that is a potential common cause of two other variables. So essentially what we have here for just 3 variables, it is just a simple partial correlation. But already 3 different models are possible, because one of these 3 variables can take turns being this common cause. So the total number of models that we can have here is 3. The second type of model that we are going to explore today in very much detail is called multiple regression. It is a situation when we have several predictors and an outcome variable, and we want to separate the variance of outcome variable into the variance associated with different predictors. So the substantial question that we ask here, are children who more optimistic more likely to get good grades, or are children who have higher self-esteem more likely to get good grades? Of course, we can apply here a causal logic and say, is it optimism or self-esteem that motivates or predicts getting higher grades? Unfortunately, because here we just had a cross-sectional design, we measured all those things we can assume at the same time. There is no way that we can make any causal claims. So when we say something predicts something else, like here, for example, psychological characteristics predict school achievement, it does not mean that there is a causal association. When we say predict, we just mean that by knowing one thing, we can kind of make a prognosis of what are the values of another variable. And this prediction can rest on simple statistical association, which might not necessarily be causal. It might be caused by some other variables. So this is a multiple regression model where we have 2 predictors and 1 dependent variable. And here on the right we have the proportion of variance of this dependent variable that was not explained by any predictor. So it is shown with little line here. And this is a multiple regression model. But then again, one of these variables can take turns being an outcome. So 3 different models are possible. Well, okay, 7 models, that's not too many. However, there are many more models possible. The third type of model that we are going to discuss today is called moderation. Moderation is an interaction between different predictors. So essentially, it is the same as a multiple regression model. However, there is here a third variable, which is optimism crossed self-esteem. It is basically a product of optimism and self-esteem, and today we'll explore how can we actually model these interactions. And the logic behind this model is that if children are optimistic and they have high self-esteem, they get better grades. But maybe if they are both optimistic and have high self-esteem, they get still better grades than just knowing their optimism and their self-esteem alone. So the idea, just like in the interaction effect in an experimental design, the idea is that if you have optimism and self-esteem together, something starts to happen. They have some kind of additional synergistic effect, which contributes to your school achievement. So this type of model, where we have 2 predictors and some interaction effect between those predictors, we call it a moderation model. And of course, here we can have again 3 different models based on 3 different regression models. So one variable in turn can be an outcome. A fourth type of model that we are also going to explore today is called mediation. Mediation is a type of model where we have a theoretical expectation of a causal sequence. There is a variable x, which is a cause, then there is a variable y, which is an outcome, and there is a variable m, mediator, which is a consequence of this cause and a cause of this outcome. So the logic here would be children who have higher self-esteem make more optimistic attributions, and thanks to these optimistic attributions, they obtain higher school grades because they believe in their success, and as a result, they invest more effort into learning. So if this causal theory is true, we can test this mediation model and get some result. And then again, in this mediation model, each one of the three variables can take turns being an outcome. And also, mediation can go in two different directions. Maybe children who get better grades, it's a success. They attribute this success in an optimistic way, and because of this, their self-esteem increases. So the direction of this association can be any. It can go in both directions. And this is the fourth type of model, which is called mediation. And finally, we can actually combine mediation and moderation in one model, so that we have a cause, for example, self-esteem, we have a mediator, which is optimism, and we have an outcome, which is our academic achievement. But maybe there is additional effect on academic achievement of a combination of self-esteem and optimism. So if they come together, there is still additional contribution to academic achievement. So essentially, it's a mediation where we added an interaction term, and we can call this model a mediated moderation model or a moderated mediation model. These terms are extremely confusing, so I would just prefer calling this type of models conditional indirect effects. And today we'll explore what is an indirect effect and why is it conditional. So I hope that your mind is not blowing up yet because of all this complexity. We have already counted 19 different models that are possible with just 3 variables. And all these models are linear. So we did not even try to look at nonlinear models. For example, quadratic associations. Maybe the association between optimism and school achievement is not linear. Maybe there is some kind of quadratic effect. And there are also other possibilities. So we will not even go into that complexity, but in principle, the number of possible models, even for 3 variables, is probably almost infinite, because you can model this association with different functions, quadratic, cubic, polynomial, logarithmic, exponential, logistic, etc. But today, we will only confine ourselves to linear associations. And we will only focus on models that deal with observed variables. Like here, each of these variables is basically a score that we have either calculated based on a questionnaire or we measured based on objective school achievement. And for the rest of today, we will explore these linear models. The question that people very often ask me when we discuss this topic, how can you actually choose between different models? Maybe it's possible to use some kind of automatic statistical procedure that will develop a model for you. Unfortunately, I hope that you now realize that the number of possible models exceeds the capabilities of any computer, and often it is actually a stupid and meaningless model that fits the data much better than a theoretically meaningful model. So there is completely no way to choose a model automatically. The only good basis for the choice of a statistical model is your theoretical understanding of the reality that you are studying. So we start by describing the nature of these variables that we are interested in. What kind of causal processes link them? And based on this explanation, we can then proceed to develop a statistical model. Okay, so after this little introduction, let's start exploring multiple regression.